Tokens and embeddings. Imagine trying to explain a Hindi movie to someone who only speaks English. So first, you'd need to translate the words, right? Similarly, computers don't understand the text the way we humans do. They need to find out a way to convert our words into numbers. And this particular conversion is what we call tokens and embeddings. So let's deep dive into this magical language of AI and try to understand tokens and embeddings. So how does the general process starts? Let's try to first understand the word tokens in general. So when we talk about tokens, tokens are nothing. It's a small piece of text. It could be a word, right? Or it could be a part of word, and it could be sometimes even a single letter or symbol, right? Now, why do we need to do this? Because breaking sentences into smaller chunks makes it easier for computers to process. Let's take an example. India is beautiful. There's no doubt about it. So when we actually break this down into a small token, we can, easily mention that, hey, look, this India is basically one token, is becomes one token, beautiful can be another token, and this full stop can be one token. So we have like, four tokens at this point. Now the whole idea is, actually this is the whole concept of tokens, but if we actually break it down into smaller words, so some models don't exactly break the entire things into smaller words, but they break down into something called as the subwords using a technique called as the byte pair encoding, famously called as the BP. So why do we need, these, byte pair encoding in the first place? Why do we need to, break it down into subwords, and why not into the words in general? Now let's take a small, word, another word, uh, unbelievable, right? Now, if you see this, word in general, this word can be basically broken down into, multiple parts. Like un can be one word, right? Believe can be one word, right? And able can be one word. Now, this helps the model handle new or rare words better. Some words which might not be present in your word list while you're basically training the model. So in those kind of scenarios, these kind of breaking down into a smaller part can basically help the word in a much better way. So for example, this basically solves. So even if a new word like unbelievableness, right? Even if a new word like unbelievableness basically comes into play, the model can still understand by breaking it into known pieces, which we just now saw, in the entire, part itself, right? So model can now, break it down into more pieces, and then, it can work around. Here, there are a couple of, important points. So basically, if we say, um, tokenization is basically the first step where the model chops the entire sentences into manageable parts it can work with. Now, the whole idea is why tokenization matters so much. Without the proper tokenization, long words would be very confusing. Right? It can be very, very confusing at times. New words might break the model. And third is training would be extremely inefficient. So there are three parts, which is why we need tokenization in the first place. First, you know, not to make sure, the model get confused because long, words basically make the model confused. Making sure, the model does not break with any new word. And third, removing the inefficiency, while training it. So these are the three reasons, like, why we basically need a proper tokenization. So tokenization allows computer to handle any sentence, even if they have never seen it before. It makes language processing faster, cheaper, and smarter. Now, once we have done with the tokenization, the another part, comes across is something called as the embedding, embeddings. Now, so I'll just, remove the entire part and I'll just write it down, the embedding from the scratch once again, embeddings. And this is the second part, after the tokenization. So tokenization basically, gives the, entire sentence into a small token. And when we take an example like previous example, which is India is beautiful, right? It basically broke down. We basically broke down into four different, tokens altogether. But the problem with the computers are computers don't understand words directly. So computers can only understand numbers like zeros and ones, or probably matrices, right? And probably vectors. So in all, like it's just corresponding to the numbers, and that's what the computers basically work around. So we need to find out a way to convert each token into numbers, and these numbers cannot be random numbers. It should be a meaningful number. And this meaningful number representation is basically called as the embedding. So embeddings are nothing, it's just you know, a number, meaningful numerical representation of the token. That's it. So for example, if you take a, token like India, and if you have to basically do an embedding for it, this becomes a list of numbers. So for example, if I have to embed, India, it can be something like 0.12, 0.85, minus 0.44, something, it can be anything, right? It can be a long list. And each number that you're looking into, right, this carries some sort of the information about India. Maybe it can be about place, maybe it can be about a country, maybe it can be about a noun or anything around it, right? So embeddings basically helps model understand the relationship between the words. So India in relationship with place, what's the number around it, right? India with the word country, what's the number behind it, and so on and so forth. So embedding basically helps the model understand these sort of the relationship between the words altogether. Now let's try to understand another example, which is a very classic example of a cat and dog, right? So if we look into the cat and dog, okay, the embedding for cat and dog will be very close, right? And the reason why it will be close is because both of them are animals. On the other hand, if we take another word like cat and cars, right, the embedding will be far away. Why? Because these are not related to each other. So let's say embeddings are uh, dimensional 768 dimensional vectors altogether, which means other example, which is king might be something like zero point 0.5, something like that and stuff like that, right? Similarly, queen will be very close to king in this particular space. The vectors of the queen will be very, very close to king. So distance between the embeddings show the semantic similarity. So when you basically calculate the distance between the embeddings, you basically talk about something called as you basically make a semantic similarity. This similarity basically shows us that these two words are related to each other. So let's not put it all together. So when you basically, type into the chat GPT, right, a sentence, okay, so how does the entire process basically works, right? So first you send let's say you wrote a sentence, right? Since this sentence is basically getting, tokenized. After the tokenization is happening, they basically go to they basically are getting embedded, right? And then after doing all sort of the calculations, on the numbers and predictions and everything which happens on top of it, it finally generates an answer, generate output, right? All the calculations and everything basically happen. Now, if I have to talk about in a bit more technical workflow, right? So technical workflow looks like that you put up an input text. This input text goes to something called as the tokenizer. Now, this tokenizer basically convert them into like a token ID. So if token gets an ID, then they basically go to a embedding layer. Here, they basically get converted into something called as the numerical vectors. After the numerical vectors, they are basically passed into the transformer layer. And after the transformer layer, they basically go to an output predictions. So these are transformer layers are nothing. It's like a self, attention layers, something which we already saw about the attentions and everything in the previous video. So it's something which basically talks about in the transformation layer itself, right? And then you finally get an output layer. So this is how the entire workflow of technical workflow of giving an input text and generating an output basically workflow works on the LLM. So why good embeddings are important at this stage? So the whole concept basically lies on the idea of good embedding. So when you say like, hey, look, this model is smarter and everything, so the whole concept basically is based upon this, which means good embedding means smarter model. So if embeddings capture meaningful uh, data, then even with little data, the model can understand synonyms, any related concepts, contextual meaning, right? For example, bank is a little bit a river bank or financial bank example, or related concepts like doctors, hospital, patients, or synonyms like hey, happy is very near to joyful, and joyful or cheerful. So all of them are basically synonyms altogether. So embeddings form the foundation for the understanding of any language model. So the better model that you look into, they have a better embedding altogether. So that's all from this section of tokens and embedding. Let's just quickly summarize whatever we have seen so far. So we started our discussion with tokenization. That was our very first uh, discussion. The whole idea of tokenization was to break the entire text into smaller parts. Then we talked about something called as the embedding. The whole idea of embedding is to basically convert each token into some, meaningful number. Now, together, they basically, allow the machines to read, understand, and think about, about the language in general. So without tokens and embeddings, AI would still be blind to our language. So friends, understanding tokens and embeddings is like learning the alphabet of AI. This is basically the foundation on which all the great models that you'll see, be it GPT to Gemini to BERT, everything is based upon this. Now that you have understand how AI reads or words, so we'll take this discussion up front, and in the next video, we'll try to explain and understand the magic of attentions and self-attention, because in the previous example when we saw that the process, uh, so this is a self-attention and attention. So in the previous example, when we saw the process of workflow where we were, having a transformation layer, transformer layer. In the transformer layer, we talk about the attention and self-attention. That's something that we are basically going to deep dive into. So attention and self-attention, is how the AI decide what to focus on inside a sentence. Even inside a sentence, what are the things that we have to focus on? Once you have built up a meaningful relationship, what should be given more priority rather than something else? So if I get India is, whether I should go with a beautiful, whether I should go with a country, whether I should go with something else, right? This is how the AI has to decide which particular word has to keep a focus on, and that's something we are basically going to look into the next video, which is on the attention and self-attention. So thank you for now.